In this video, we're going to talk to you about proofs. And one of the proofs is with what we call side angle side congruence. We can prove that this triangle and this triangle are congruent because with a rigid motion, we can just pull this thing right over here and it will match exactly. Of course, my picture's not perfect, but you get the idea. Now, this is what this theorem is saying. If you have a triangle that has two sides that are exactly the same size, and one angle that is exactly the same side, and it is it's an included angle, then the two sides, the two triangles, are congruent by side, angle, side. Side, angle, side. We call it SAS. Okay? But I'm going to tell you something. If the angle had been up here, instead, we wouldn't be able to do it because the angle is not included. It's not included. If I could open this guy and then pull this guy down, look, if I could say, here's this side with two things, here's the angle right in the middle, and then here's this other guy with one tick mark. This is called the included angle because it's in between the two lines. But this is not in between anything because this isn't marked. You see that? So this is called side angle side. Let's see if I could draw another one for you real quick. Let's do it this way. What if I had marked this mark? Then what angle would I have to put? I'd have to put this one right here. By the way, that would have to have 3 tick marks because it's across from there. But in any case, side, angle, side. Now it works. Okay? If I had two triangles like this, and I wanted to call it this, and I said this, now I can call it side, angle, side, side, angle, side. So you get the idea? You have to start with a side, you have to go to the angle next, and then another side. All right, now we're going to do a little quick proof here. I want to show you how you can do a proof of two triangles. So suppose we have this shape. And I'm going to A, B, C, D. I want to tell you that those two lines are parallel and these two lines are congruent. And that's all I'm going to say. All right? They're asking us to write a 2-column proof. All right, so here's what's given. Well, okay. What is given is BC is congruent to AD. Also, so the other thing is, and the other thing that is given is that BC, is parallel to AD. Those two things. These lines are parallel and they're congruent. They want you to prove that ABC is congruent to CDA. All right, so we're going to make a 2-column proof. All right, here's our 2-column proof over here. Up here, we're going to have statements. And here we're going to have reasons. Remember? Now remember, you have to number them. Remember, normally we put the givens first. So number 1, BC is congruent to AD. Why? Number 1, because it was given. Number 2, BC is parallel to AD. Why? Because it was given. All right, now, we're trying to prove that these two triangles are the same. Well, remember, we're talking about side angle side, right? We already know that this triangle, this line right here, is congruent. We have to figure out 2 more sides that are the same. I mean, you know, this side. And we have to figure out an angle that's the same. All right? Well, the thing that jumps out at me is this. AC equals AC is congruent to AC. Why? Number 3, you remember this word? You look in the mirror, the reflexive property, right? All right, now we have side and side. What angle do we have to use? We have to use this guy because he is between the 2 sides. Well, how can we prove this? Remember when you have, let me just do this real quick. If I have 2 lines like this, like I do, that are parallel, and I cut through them like this, right? Then these 2 angles are the same. Well, look at this. If I do that, then this angle here, right here, and this angle here are the same. Why? Alternate interior angles. So I'm going to say, for number 4, angle A is congruent to angle C. Number 4, why? Alternate interior angles. And number 5, I'm going to write down, by the way, excuse me, I forgot something here. On this one, you're going to write down, for number 1, you're going to write down side because you've got a side right there. Here, you're going to write down another side, right? And here, you're going to have A for angle. Okay, now I've got side angle side, so I can say angle or triangle ABC is congruent to triangle CDA. Why? All you have to write, SAS. So I proved it. Why did I prove it? Because I found a side, an angle, and a side. This side jumped right out at me because AC equals AC. Why? Reflexive. I had to choose this angle because I've got this line and this line. I couldn't choose this because it's not included. I couldn't use that because it's not included. I had to use that. So when I notice that these 2 lines here are parallel, then I have these 2 angles are the same. As a matter of fact, alternate interior, these 2 angles are the same as well, but I didn't really care about those. All right, that's how we prove it.